All right, so the quiz on Friday is on sections 1.6, 2.1 through 2.3. So this is the quiz review. The first question, it says find the vertex, x and y intercepts, axis of symmetry, max and min, and write it in standard form, which is our vertex form because it's already in standard form, and then sketch the graph. So looking at our equation here, we want to start with the highest degree term. So it would be that negative x squared minus 2x plus 8. So I'm just going to rewrite it in standard form with the highest degree first. That way we can kind of see what we're doing, and it's in that ABC order. So my leading coefficient here is negative. So that means my graph is going to open down. So that answers our first question. It opens down. Next, we want to find our vertex. We find our vertex with our little formula, negative b over 2a. So b would be negative 2. So negative 2 over 2 times a is negative 1. So this would be positive 2 over negative 2, which is negative 1. So the first number in our vertex, the x, or we could say the h, is negative 1. Now to find the second number, the y part of our vertex, we take that negative 1 and plug it into the x's. So I have negative 1 squared minus 2 times negative 1 plus 8. So this negative 1 squared turns positive 1, but we do have a negative on the outside, so it's back to negative 1 plus 2 plus 8. So this would equal 9. So the y in my vertex is 9. Domain, whenever you have a parabola, your domain is always from negative infinity to infinity. Always, always, always. And remember, when you have negative infinity or infinity, you put the parentheses there. Next, we want to figure out the range. So I'm actually going to plot my vertex first, just so we can kind of visualize the way our graph looks. So my vertex is at negative 1, 9. So right there. And my graph opens down. So this isn't an actual picture of our graph. We're going to make it a little bit more exact once we get to the next couple things, but it opens down. So our range points to negative infinity. The smallest y value is negative infinity with a parentheses, and the highest y value is 9. And that gets a bracket because we don't have an open circle there. 9 is included. The highest or lowest value in your range, that number that's going to be in your range, is always going to be that same as the y value in your vertex. Now, since our graph opens down, the vertex is at the maximum. So we have a maximum, and it's always y equals whatever your y value is. So our y value here was 9, so it's y equals 9. Next, we need our x-intercept. So x-intercept is when y is 0. So we change y to be 0. So in my equation, I'm going to make y 0. So 0 is equal to negative x squared minus 2x plus 8. And we're going to solve for x. So we're going to have to factor here, but before we factor, we want to make sure our leading coefficient is positive, just to make it easier to factor so we don't have to end up multiplying the first times the last. So we want to make sure that it is a positive number. So I'm just going to divide everything by negative 1, take out a negative, change the signs of everything, and factor from here. So 2 factors of negative 8 that add to 2 would be 4 and negative 2. So in our parentheses, I have x plus 4 and x minus 2. Now we took out a negative, but I could just divide this whole side by negative 1 and divide 0 by negative 1. 0 divided by negative 1 is still 0, so it doesn't change the value, and we don't really need it anymore. So we can just get rid of it by dividing this side by negative 1 and the left side by negative 1. So now from here, we just want to set each little piece equal to 0. So x plus 4 equals 0. X minus 2 equals 0. Subtract 4 on both sides, so x is equal to negative 4. Add 2 to both sides, x is equal to 2. So our two x-intercepts are negative 4 and 2. For our x-intercept and y-intercept, they have to be coordinate points. So x-intercept is the x value, so it's negative 4. We plugged in 0 for y, so the y is 0. And then 2, 0. Again, we plugged in 0 for y, so that's why our y is 0. The y-intercept, we're going to plug in 0 for x. So I have y equals negative x squared minus 2x plus 8. I'm going to plug in 0 for x. So I have 0 and 0 here. So negative 0 squared minus 2 times 0 is 0. So 0 plus 8 would just be 8. So our y-intercept is 8. This has to be a coordinate point. So we plugged in 0 for x and got 8 for y. So our y-intercept is 0, 8. Now we can plug these 3 points in, our x-intercepts and y-intercept, to help us graph this a little bit better. So I'm going to leave my vertex there. My x-intercept is negative 4, 0, so I'm going to go to the left to negative 4, stay on 0, put a point there. And 2, 0, so go to the right 2, stay on 0, put a point there. And I can also graph my y-intercept, which is 0, 8, so there. And then we just connect the dots. So there's our graph. Last thing we want to do is put it in vertex form. So I start, vertex form is y equals a times x minus h squared plus k. I'm going to plug in my a, my h, and my k. So a comes from the coefficient, that leading coefficient, so in front of the x squared, so that would be negative 1, or here we could just say negative. So we have x minus h, so minus negative 1 becomes a plus 1 squared, and then plus k would be plus 9. So that is our vertex form. All right, let's take a look at number 2. So let's put this in standard form first. I have x squared minus 4x minus 5. So here my a is 1, it's positive, so my graph is going to open up. So it opens up. Next, we can find our vertex. We need our handy-dandy formula, negative b over 2a. So my b would be negative 4, so that is a negative 4 over 2 times 1. So it's positive 4 over 2, which is 2. So my x in my vertex is 2. Now to find the y, we plug in the x into the x's. So 2 squared minus 4 times 2 minus 5. This would be 4 minus 8 minus 5. So negative 4 minus 5 is negative 9. So my y is negative 9. We can go ahead and graph that. So go to the right 2, down 9. Put a point there. And we said that it opens up. So it's just a rough estimate of our graph for now. We can make it a little bit more exact once we find the x-intercept and y-intercept. But it will help us with the domain and range. So the domain is always all real numbers, negative infinity to infinity, with parentheses. Our range, we start at the lowest y value and go up. So our lowest y value here would be negative 9. So we put a bracket, negative 9, and it goes up to infinity. Now, since our graph opens up, the vertex is at the minimum point, and our minimum is always the y value. So our minimum is y is equal to -9, because it's whatever the y value is. So that y value gets repeated as the y here in our range and in the max or min. Now let's find our x-intercept. For the x-intercept, we make y 0. So 0 is equal to x squared minus 4x minus 5. We need two factors of -5 that add to -4, so that would be -5 and 1. So my parentheses, I have x minus 5 and x plus 1. So when we set both of these equal to 0, we'll get x is equal to 5 and x is equal to -1. So our x-intercept has to be a coordinate point. So in my parentheses, I put it in parentheses, I'll have 5, 0, because I plugged 0 in for y. So y goes in the 0 spot. 0 goes in the y spot. My second point will be -1, 0, and 0 goes in the y spot there. Next, I want to find the y-intercept, so I plug in 0 for x, so 0 squared minus 4x minus 5, or minus 4 times 0 minus 5, so y is equal to -5. So I plugged in 0 for x and got -5 for y, so my coordinate point is 0, -5. And lastly, we can put it into vertex form, so y equals a times x minus h squared plus k. Our a is just 1, so we don't need to write our coefficient of 1. X minus h, so minus 2 squared plus k, which is -9, so it'd be -9. And then we want to fix our graph a little bit. We can keep our vertex there, but let's plot our x and y intercepts. So my x-intercept is at 5, 0, and -1, 0. My y-intercept is at -5. So I can just connect these dots with my parabola. There's my graph. All right, for the next question, we have to determine whether the given quadratic function has a minimum value or maximum value, then find the coordinates of the vertex. So because a is positive, our graph is going to open up. So we have a minimum value at our vertex. So that would be a minimum. In order to find out what our minimum is, it's going to be the y in our vertex. So let's find our vertex. So we're going to use our formula -b over 2a. That would be -2 over 2 times 3. So this turns out to 2 over 6, which simplifies to 1/3. So the x coordinate in our vertex is 1/3. Now to find the y, we need to plug it in. So I have 3 times 1/3 squared minus 2 times 1/3 plus 1. I'm going to square my 1/3, so 1 gets squared and 3 gets squared. Make sure if you have a fraction, you square both the top and the bottom. So this would be 1 over 9 times 3, and then minus 2/3 plus 1. When I have 3 over 9, I could simplify that to 1/3. So 1/3 minus 2/3 plus 1. I can change 1 to be 3/3, and then we can just add our numerators together. So 1 minus 2 would be -1, plus 3 would be 2/3. So make sure you guys know how to multiply and add fractions. So my y value in my vertex is 2/3. So my minimum value would be y is equal to 2/3. All right, let's take a look at number 4. For 4 and 5, we want to use the leading coefficient test to determine the end behavior of the polynomial. We want to find the number of turns, the x-intercepts, the multiplicity, the y-intercepts, and the graphs. So for number 4, I'm going to put it in standard form first because it'll make it a little bit easier for us to factor once we need to. So we have 2x cubed plus 3x. We look at the highest degree to determine the end behavior. So since 3 is odd, that means they go in opposite directions, and 2 is positive. So the right arrow is going to go up and the left arrow goes down. So the end behavior, we would say, falls left and rises right. To find the number of turns, that is n minus 1, which n is our highest degree. So since our highest degree is 3, it'd be 3 minus 1, which is 2. Now to find our zeros, we have to factor it. So that's when y is equal to 0. I have 2x cubed plus 3x. To factor this, I'm going to take out my greatest common factor, which is x. Then I'm left with 2x squared plus 3. So I could set both of these equal to 0. X equals 0. 2x squared plus 3 equals 0. So this is already solved. That's one of our zeros. And then to find the other one, I'm going to solve for x. Subtract 3 on both sides. 2x squared is equal to negative 3. Divide by 2. So x squared is equal to negative 3 halves. Take the square root. I cannot take the square root of a negative number, so this is not a real 0. So the only real 0 that I have is x equal to 0. Next, I want to state the multiplicity. So the multiplicity at 0 would be 1. So I have multiplicity of 1 at 0. Or we could say at x is equal to 0. Next, I'm going to find the y-intercept. So that is when x is 0. So I'm going to plug 0 into my x's. So 2 times 0 cubed plus 3 times 0, which would be y is equal to 0. X and y intercepts are always a point, so that would be 0, 0. And then last thing we could do is graph it. The only place that I cross the x and y axis is at 0. And then my graph is going to have that x cubed type of shape, so it falls to the left and then rises right. So it'll look something like this. All right, next let's take a look at number 5. So we're going to look at the highest degree first. So that would be x to the 4th power. The degree is even. So that means our arrows are going to go in the same direction. And it is positive. So that means the right arrow goes up, and since they go in the same direction, the left arrow goes up. So my end behavior would be rises left and right. And then next we can state the turns, which is our degree minus 1. So it would be 4 minus 1, which is 3. And then next we want to find the zeros. So we're going to have to factor. So when you have 4 terms, we always want to check and see if we can factor by grouping. So luckily here we can. I'm going to group the first 2, group the second 2. In my first group, I can take out an x cubed, and I'm left with x minus 6. In the second group, I can take out a negative 2x, and I'm left with x minus 6. You always, always, always need the same thing inside the parentheses in order to factor by grouping. So if you didn't get the same thing, you may need to take out a different GCF. If taking out a different GCF doesn't work, then you probably can't factor by grouping. So here, the inside parts go together. X minus 6 is our first group. Then the outsides go together, so that would be x cubed minus 2x. So I'm going to write that on the side so we can factor a little bit more to find our zeros. So x minus 6 is already factored, can't break that down anymore. In my second group, I can actually take out an x from there, so I'm going to pull out an x to the outside. So take out an x, I have x minus 6, and then this is what I'm taking out the x from, but I just wrote it in the front. Here I have x squared minus 2. So now we can set each piece equal to 0. X equals 0, x minus 6 equals 0, and x squared minus 2 equals 0. So x is equal to 0 is a 0, already solved. Next one, I'm going to add 6 to both sides, so x equals 6. The third one, I'm going to add 2. So x squared is equal to 2, and take the square root. Always remember, whenever you take the square root of both sides, you need that plus or minus sign. So plus or minus square root 2. So our 4 zeros here are 0, 6, positive square root 2, and negative square root 2. Now I only have one of each of these, so I have multiplicity of 1 at x is equal to 0, 6, square root 2, and negative square root 2. Next, I want to find the y-intercept, so that's when x is equal to 0. So I'm going to plug in 0 for all of my x's. So 0 to the 4th power minus 6 times 0 to the 3rd power minus 2 times 0 squared plus 12 times 0. We get y is equal to 0. So my y-intercept is 0, 0. Now I can graph my zeros and the y-intercept. My y-intercept is at 0. My zeros are what I'm going to graph next. So x is equal to 0 would be a point at 0, but that I already accounted for in the y-intercept. Next, I have a point at 6 on the x-axis, square root 2 on the x-axis, so that would just be a little bit more than 1, so somewhere in here. And then negative square root 2. And then I'm going to put my arrows, so I go up to the left and up to the right. And at each one of these zeros, I go through, because my multiplicity is 1, so I go through all of these points. So I'm going to go through the x-axis, through the x-axis, through the x-axis, and through the x-axis. So my graph looks like that. All right, for number 6, we're doing the same thing, but this one's already factored for us. So here, to find the zeros, I'm going to make y 0. Just set each little piece equal to 0. X minus 2 equals 0. X plus 1 is equal to 0. X plus 2 is equal to 0. And there's actually 2 of these, so I have another x plus 2 equals 0. Then I solve. So add 2 to both sides. We get x is equal to 2. Subtract 1 from both sides. X is equal to negative 1. Subtract 2 from both sides. X is equal to negative 2. And x is equal to negative 2. So these are my zeros. I have 4 zeros. So my degree would be 4. And the amount of turns I have is n minus 1. So that would be 4 minus 1, which is 3. My zeros are x is equal to 2, negative 1, negative 2. You could list it twice, but you don't need to. I have multiplicity of 1 at 2 and negative 1, and I have multiplicity of 2 at negative 2, because I have 2 negative 2's. I had 2 negative 2's. So when my multiplicity is 1, 1 is an odd number, so I go through the graph at 2 and through the graph at 1. But when my multiplicity is 2, since 2 is an even number, and I have 2 negative 2's, at negative 2, I touch and turn. Next, I want to find the y-intercept. So just plug in 0 into all of my x's. So I have 0 minus 2, 0 plus 1, 0 plus 2 squared. This would be negative 2 times 1 times 2 squared. So negative 2 times 4, which would be negative 8. So my y-intercept has to be a coordinate point. So I plugged in 0 for x and got negative 8 for y. Lastly, we want to find the end behavior. So this one's a little bit different because it doesn't give it to us in standard form. But I have 4 x's here because the last one is squared. So this would be an x to the 4th power graph. And none of those x's in the equation here have a negative sign in front of it. So it would be a positive x to the 4th graph. So because 4 is even, they're going to go in the same direction. And because it's positive, they go up and up. So we would say rises left and right. All right, for number 7, our highest degree is 2. So that means turns would be 2 minus 1, which is 1. We can also find the end behavior. So since our degree is 2, it is even. So that means they go in the same direction. And our leading coefficient is negative. So they're going to go down and down. So we would say falls left and right. Next, I can find the zeros. So I'm going to have to factor it. When our leading coefficient is not 1, we factor by multiplying the first times the last. So that would be negative 3. 2 factors of negative 3 that add to negative 2 would be negative 3 and 1. So in my parentheses, I have x minus 3 and x plus 1. Since I started by multiplying negative 3, I have to go back in and divide both the numbers by negative 3. So here I have x plus 1, and if it doesn't simplify, we move it to the front. So negative 3x plus 1. Then set each of them equal to 0. So x is equal to negative 1. And then negative 3x plus 1 is equal to 0. Subtract 1 to the other side, so negative 3x is equal to negative 1. Divide by negative 3, so x is 1/3. So our zeros would be negative 1 and 1/3. Since I only have one of each of them, I have multiplicity of 1 at those 2 points, so negative 1 and 1/3. And then to find my y-intercept, I would plug in 0. So I have negative 3 times 0 squared minus 2 times 0 plus 1. So this would be just 1. So since these are zeros, anything with a x in it, you can just ignore. We're just looking at the constant here, which is 1. So I plugged in 0 for x and got 1 for y. All right, for number 8, we have to divide using long division. So I'm going to start with negative 4x minus 3 on the outside, and 8x cubed plus 18x squared plus 13x plus 5 on the inside. So we start by seeing what times negative 4x would give us 8x cubed. So that would be 2x squared. Negative 2x squared, because it has to multiply and give us that positive 8. Same thing here. It's like dividing this by negative 4x. So 8 divided by negative 4 would be negative 2. And x cubed divided by x would be x squared. So after we write that up top, we multiply it by both things on the outside. So negative 2 times negative 4 would be 8. X squared times x would be x cubed. And then negative 2x squared times negative 3 would be positive 6x squared. Change a sign, and combine. So these cancel. 18x squared minus 6x squared would be 12x squared. Then we do it again. 12x squared divided by negative 4x would be negative 3x. Multiply, we get 12x squared. Multiply negative 3x with negative 3, and we get positive 9x. Change a sign, and combine. So these cancel. I'm going to bring down the 13x. So 13x minus 9x would be 4x. Then we divide. Negative 4x goes into 4x negative 1 times. Multiply. We get negative 4x. This would actually be positive 4x because it's negative 1 times negative 4, and then positive 3. Change a sign, and combine. So these cancel. Drop down the 5. 5 minus 3 would be 2. So our remainder is 2. That's our answer. All right, for number 9, we're going to do the same thing. So 3x minus 4 goes on the outside. 12x cubed minus 10x squared minus 17x plus 12 goes on the inside. So I need to think what times 3x squared gives me 12x, or I can divide it. So 12 divided by 3 would be 4. X cubed divided by x is x squared. So 4x squared. Then I multiply. 4x squared times 3x would be 12x cubed. 4x squared times negative 4 would be negative 16x squared. Change a sign, and combine. So these cancel. Negative 10x squared plus 16x squared would be 6x squared. Then we divide. So 6x squared divided by 3x would be 2x. Then we multiply. We get 6x squared minus 8x. Change the sign, and combine. So drop down the negative 17x. Negative 17x plus 8x would be negative 9x. Divide that by 3x, we get negative 3. Multiply, we get negative 9x plus 12. Because negative 3 times negative 4 would be positive, so positive 12. Change a sign, and combine. Drop down the 12. 12 minus 12 is 0. So here we have no remainder. So our answer is just 4x squared plus 12x minus 3. Next, we're going to divide using synthetic division. So when it's given to us as a binomial like this, we change the sign of what goes outside. So a negative 2 is going to go outside of our box. And then we have to make sure every coefficient for every degree is represented. So I have x to the 5th power, 4, 3, 2, 1, and our constant. So we're good. So I'm going to put my coefficients, 1, negative 3, negative 7, 1, negative 1, and positive 18. Drop down the 1, multiply, add, multiply, add, multiply, add, multiply, add. We get 9, negative 18, add, 0. So since our remainder is 0, that means that x plus 2 is a factor. So we could say yes. Yes, it's a factor. All right, now we're going to do the same thing for 11. So I'm going to change the sign to make it a positive 6 on the outside. Now here I'm missing x to the 3rd power, so I'm going to put a 0, x to the 3rd power. I'm missing x squared, so 0, x squared. And I'm missing an x, so 0, x. So I have 1, 0, 0, 0, 1,296. Drop down the 1. Multiply, add, multiply, add. Multiply, we get 216. Add, 216, multiply, 1,296. Add, and we get something that is not 0. So here, x minus 6 is not a factor. So we would say not a factor. Because this ends up being 2,592, which is not 0. All right, for number 12, we use synthetic division and the remainder theorem to find the indicated function value. So we are using negative 3 as our number on the outside, and all of our coefficients go inside. So I have x cubed, x squared, x, and a constant, so I'm not missing anything. So we are good to plug in our coefficients into the box. So I have 4, negative 8, negative 4, and 23. Drop down the 4, negative 12, add, we get 20, negative 20. Multiply, this becomes positive 60, add, 56, multiply 56 times 3. 168, negative 168. And then we add. So this would be negative 145. So f of negative 3 is negative 145. For 13, we have to solve given that 1 is a root. So 1 is a solution. So I can divide by 1, so use synthetic division with 1 on the outside. My coefficients go on the inside, so 12, negative 25, 16, and negative 3. Drop down the 12, multiply, add. This would be negative 13, add, multiply. So we get negative 13, then add. This would be positive 3, multiply, add, we get 0. So yes, 1 is a root, that was given, but I wanted to divide it anyways because now I have an x squared. Since I started with x to the 3rd power, this is now x squared. So I can factor this. So I have 12x squared minus 13x plus 3. So I'm going to write it on the side over here. 12x squared minus 13x plus 3. So we can factor. So whenever we have a number in front of our x squared, our leading coefficient, if that is not 1, we have to start by multiplying the first times the last. So 12 times 3 would be 36. I need 2 factors of 36 that add to negative 13, so that would be negative 9 and negative 4. So x minus 9 and x minus 4. since I started by multiplying 12, I want to make sure I divide both of these by 12. Simplify where we can, and whatever we can't simplify, the denominator is going to go in front. So here, I can divide both of these by 3 and make it 3 over 4. So then the 4 is going to go in front of the x, so that becomes 4x minus 3. And then with my second fraction over here, I can divide them both by 4. So this would become 1 over 3. So the 3 is going to go in front of the x. So 3x minus 1. This question's asking us to solve. So we set both these equal to 0. So 4x minus 3 is equal to 0. 3x minus 1 is equal to 0. Add 3 to both sides. 4x is equal to 3. Divide by 4. And x is equal to 3/4. Do the same thing with our other equation here. Add 1 to both sides. So 3x is equal to 1. And divide by 3. So x is equal to 1/3. So these are the other two solutions. So one is a root, one is one solution, one is a solution, and our other solutions 3/4 and 1/3. Right, with 14, we're using synthetic division to find the roots of the polynomial, given that x is equal to -3 is a root. So -3 is going to go outside because it said x is equal to, so I just put that number outside. Now, inside the box, I have to put my coefficients, but make sure that they are in order. My x squared is last over here, so I just want to make sure everything's on one side of the equal sign and make sure that it's in standard form. So I have x cubed plus 3x squared minus 4x minus 12. So if you had a number over here on the right side of the equation, you'd have to move it over. Or if it's not in standard form, you have to make it in standard form. So my coefficients would be 1, 3, -4, and -12. So drop down the 1, multiply, add, we get 0. Multiply, 0, add, -4, multiply, +12. We add, and we get 0. So we just verified that x is equal to -3. And now here we have an x squared equation, so we can solve this by factoring. So x squared plus 0x minus 4, which is just x squared minus 4. Now I can factor this because x squared is a perfect square, 4 is a perfect square, so I have the difference of squares. So this turns into x plus 2, x minus 2. Or a different way you could think about this, or what are two factors of -4 that add to 0? That would be +2 and -2. So we set them both equal to 0. We get x is equal to -2 and x is equal to +2. So in addition to -3, we have -2 and +2. So those are our 3 roots, or our 3 solutions. All right, number 15. We're doing the same thing. So we want to factor the polynomial if x plus 2 is a factor and use synthetic division. So this says x plus 2. So since it's written as a binomial, we change the sign and make it -2 on the outside. And then with my polynomial, I want to put it in standard form so I know which coefficient goes where. So I have 6x cubed plus 10x squared plus x plus 10. So nothing's missing. I can go ahead and plug in my coefficients. I have 6, 10, 1, and 10. Drop down the 6, multiply, add, multiply, add, multiply, add. We get 0. So 2 is a solution. 2 is a root. -2. So x is equal to -2. Works. So now we have to factor to find the rest of them. So 6x squared minus 2x plus 5. 6x squared minus 2x plus 5. I'm just rewriting it on the side so I have more space. So to find our zeros, we have to factor. Since our leading coefficient is not 1, I start by multiplying the first and the last. So I have 30, 2 factors of 30 that add to -2. we don't have factors of 30 that add to -2. So when it doesn't factor, we have to use the quadratic formula. So -b plus or minus the square root of b squared minus 4ac over 2a. Plug in our a, b, and c. So -2 turns into a +2, plus or minus the square root of -2 squared, so that would be 4, minus 4 times 6 times 5 over 2 times 5. So I have 2 plus or minus the square root of 4 times 6 times 5. 6 times 5 would be 30, and 30 times 4 would be 120. So 4 minus 120 would be -116. I cannot take the square root of a negative, so this is not a real zero. So my only real zero is x is equal to -2. All right, for the last 3 questions, we are finding the inverse. So to find the inverse, I switch my x and my y. So I'm going to make this x and make this one y, and then we have to solve for y. I'm going to rewrite it on the side over here. So I have x is equal to 1/2 y plus 7. So I have to undo everything on the right side and get it to be y equals. So subtract 7 on both sides. X minus 7 is equal to 1/2 y. Now I can multiply 2 to both sides to get rid of that 1/2. So times 2 times 2. So I'm going to distribute the 2. You don't have to, but you can just leave it outside, but make sure you put that x minus 7 in parentheses. So this would be 2x minus 14 is equal to y. So to name it, we have to put that exponent of a -1. That's just naming the inverse. So g inverse of x is equal to 2x minus 14. Again, if we didn't distribute the 2, we could just leave it as 2x minus 7. These are the same. All right, let's look at 17. So I have f of x is equal to x minus 2 cubed. So I'm changing this to be x and changing x to be y, and I'm going to solve for y. So to undo everything on the right side, I have to take the cubed root. So what I do on the right, I also have to do on the left. So I have the cubed root of x. It cancels out on the right, so y minus 2. Add 2 to both sides. So this would be 2 plus the cubed root of x. You could write it the other way and say the cubed root of x plus 2, but that 2 does not go inside the radical. So we're done. We just need to name it. This is f inverse. So again, you could also write it like the cubed root of x plus 2. Just make sure that 2 is not inside. And then last, I have 18. So I'm going to switch the x and y. I'm going to make this one x. Y goes inside. So x is equal to the 5th root of 2y plus 11. I have to raise both sides to the 5th power to get that to cancel out with the 5th root. So x to the 5th power is equal to 2y plus 11. Subtract 11. X to the 5th power minus 11 is equal to 2y. And then divide both sides by 2. So a inverse of x is equal to x to the 5th power minus 11 over 2.